Good morning, students. Today we will be starting with Science 1, Chapter 7, Lens. Good morning, students. As I said before, we will be starting with Science 1, Chapter number 7, Lens. Lens is something that we see in our day-to-day life surround in many places. For example, we see the lens that is there in our door. Then we see the lens that is in a magnifying glass, the lens that is used by a watchmaker when they're working on watches and etc. Then lenses are also used in spectacles, that is specs. They're used in telescopes. So there are many optical instruments like simple microscope or microscope, compound microscope, where we use lens in our day-to-day life. What is a lens? A lens is defined as a transparent medium bound by two surfaces. What does it mean? It's a transparent medium. That means it's not opaque, light can pass through it. And it is bound. That means it is surrounded or covered by, enclosed by two surfaces. The lens, which has two spherical surfaces which are puffed up outwards, is called as a convex lens or a double convex lens. Look at the first diagram. Biconvex, double convex, or a convex lens. It looks like two parties going outside, whereas this lens is thicker near the center as compared to the edge or the ending. The lens with both surfaces spherical on the inside is called as a concave lens or the double concave lens. If you look at the diagram, the first, second, third, the fourth one, biconcave lens. This lens is thinner at the center of as compared to the edge. When we talk about lens, it is like as if you can imagine, look at the diagram given below. It is as if there are two spheres, glass spheres, which are overlapping each other, and that forms a biconvex lens. And in case of a biconcave, it is as if you are taking two arcs of the spheres, glass sphere, and you are joining and making it. Different types of lens can be seen in the diagram. The first one, as we saw, is a biconvex. That means both the sides are convex. Then plano-convex. One side is plane, other side is convex. Then we saw biconcave. That is both the sides are concave. Then we have plano-concave. One side plane, one side concave. So these are some of them. A ray of light gets refracted twice while passing through a lens. A very important point. We learnt about refraction in the previous chapter, and we saw that refraction means when it is bending, light bending when it travels from one medium to another. And here, since there are two surfaces, so light gets refracted twice. Once while entering the lens and once while emerging or coming out of the lens. The direction of the ray changes because of this refraction. Both the surface of most lenses are parts of its sphere. Certain definitions related to convex lens as well as concave lens. If you look at the diagram 7.3, the A part is showing how a convex lens is made. It's overlapping two spheres, and if you're cutting the arcs and forming the two spheres, you get a biconvex lens. Similarly, the B part is showing a biconcave lens. The first definition that we see is called center of curvature. Now, since it is a lens is made using two spheres, everything is double or everything is twice. So here also we have two center of curvature, two radii of curvature, things like that. So center of curvature, how do we define center of curvature? The center of sphere whose parts form the surface of the lens are called center of curvature of the lens. So the center of the sphere, we have a big sphere over here and a smaller sphere. You can see S1 and S2. So C1 is the center of sphere S1 and C2 is the center of sphere S2. They are called as the center of the circle, and in this case they are called as the center of the curvature. Radius of curvature or radii of curvature. Radius, we know what is a radius in case of a circle. Similarly here also, the radii of the sphere whose part forms the surface of the lens are called the radii of the curvature of the lens. So the radii or the radius of sphere A, that is R1, whereas radius of sphere B, that is S2, and C R2 is the two radii of curvature. What is principal axis? Principal axis is an imaginary line passing through both the center of curvature is called as the principal axis of the lens. You can see, if you imagine, there is a line passing through both the centers. Optical center. Optical center is O. Look over there on 7.3, as well as you can see on the right hand side of the. What is optical center? The point which is inside a lens on the principal axis, such that through which light rays pass through without changing their point, is called the optical center of the lens. If you compare it with a mirror, when we have learnt a mirror, we have learned that the center of the mirror is where the ray of light passes without deviating. Similarly, it is the center of the lens. But what you have to remember over here is O, or optical center, is the center of the lens, not on the surface, because if it is on the surface it will be two optical centers, but here we are talking about only one optical center. If you look at the diagram over here, you can see that O is the optical center that is shown over here. Principal focus. Since we have two types of major lens, that is convex lens as well as concave lens, the principal focus differs little in case of a convex lens as well as in a concave lens. First, we will be defining the principal focus of a convex lens. When rays of light parallel to the principal axis are incident on a convex lens, they converge to a point on the principal axis. This point is called the principal focus of the lens. Now look at the diagram A and let us understand what it means. Rays of light parallel to the axis. Look at the blue rays of light. They are parallel to the principal axis. They converge to a point. That means they fall on the lens and they get diverted or deviated according to the laws of refraction, and they converge or meet at a point F2 shown by the parallel rays of light. Now this point is called as the principal focus of the lens. Similarly, if you are considering from the opposite side, then F1 becomes the principal focus. Now the light rays parallel to the principal axis falling on a convex lens come together. That means they meet at a point, and that is why a convex lens is also called as a converging lens. Now you look at the other one, that is the B part of the diagram. Rays traveling parallel to the principal axis of a concave lens diverge after refraction in such a way they appear to be coming out of a point on the principal axis. This point is called the principal focus of the concave lens. Look at the diagram again. If you see the blue lines, they are the rays of light which is parallel to the principal axis. When they fall on the lens, they diverge. That means instead of coming together, they go away from each other. See the purple lines going out in the opposite side. Now if you retrace them backward, they appear to meet at a point F1, and this is called as the principal focus of the concave lens. Similarly, in the opposite side, if you are considering, then F2 becomes the principal focus. The difference between a convex lens and concave lens is that convex is called as a converging lens, whereas concave is called as a diverging lens, because after the rays of light falls on them after refraction, in case of a convex they meet at a point, in case of a concave they go away from a point. Also another thing is that in case of the focus of a convex lens is called as a real focus because it is meeting at a point, whereas the focus of a concave lens is considered to be virtual because it appears to be coming from a point. Then what is focal length? Focal length is the distance between optical center and the focus. That means in this case, it will be the distance between O to F1 or F2, either for convex lens or for concave lens. We need to understand especially the principal focus part as well as the focal length, because we will be requiring this when we are drawing the ray diagrams or diagrams to show the concave lens and the convex lens.